So exponential growth, and this is a lot, you're going to use this a lot with banking, occurs when a quantity increases exponentially over time. So the formula for exponential growth is y equals a times 1 plus r to the t. Okay. And so what you're doing is you're taking 100% of what's there and then you're adding the rate. A is our initial amount. We already wrote that down. Okay. A is how much you walk into the bank with, or if you're doing like a bacteria question, it's how much bacteria was in the petri dish to begin with. Okay. Rate is the R is your growth rate, and you have to put this as a decimal because 100% is written as 1. So we've already written that as a decimal. Okay. And then T is our time. Normally this is in years, but I have seen some questions over the years where it's not in years. Not in Algebra 1, because this is just kind of an introduction to using this. So on the first question, the original amount invested. So the original amount invested is $1,400. That's how much they walked into the bank with. And so you're looking for that and you're looking for that, right? So I know that. Okay, the value increases by 9%. So I'm gonna highlight the increases. I don't really need to because this page is about growth, so they're all gonna be increasing. But when you mix these together, you have to look for those words. Use an exponential growth function to find the value after 25 years. Okay, so they want me to plug those things into that formula. So it's 1,400 I walked into the bank with, 1 plus 0.09 to the 25th. Okay, so I'm going to plug that in and I'm going to figure out how much money is in the bank when I am done. So I started with $1,400, parentheses, 1 plus 0.09 because it was a 9% growth. And I left it in there, so I'm going to use that caret key and to the 25th. So this is money, so I'm going to round it 2 places. So my answer is $12,072.31. So $12,072.31. Okay, so this section is mostly just kind of getting you used to seeing this growth. In Algebra 2, we'll do a lab that helps us like in the real world figure this out, and I'm going to try to do that lab with you sometime when we're meeting so this makes sense. But I just never, I'm making these in July. This is July 17th, and you're probably doing this like in February. So I just didn't know when that would be. So if we've done the Skittles lab, awesome, you get this. If we haven't, the next time we meet, we're going to. Okay, so when I read the next question, it says the cost of tuition is $12,000. It's increasing by a rate of 6% each year. Use it to find the tuition after 4 years. So $12,000 is my initial value because that was the cost. It's increasing at 6%, and you're doing this for 4 years. So when you write your equation, you're going to say 12,000 times 1 plus 0.06. You have to move it 2 places to the 4th. And then you're going to type that into your calculator, and you have to remember this is money, so you're going to round it 2 places. So $15,149.72. Okay. All right. So what I would like you to do is I would like you to do 3 and 5. Pause and do 3 and 5. Okay, the number of student athletes in a local high school is 300 and is increasing by 8% per year. Use an exponential function to find the number of athletes. So 300 is my initial value. That's how many. It's increasing at a rate of 8% per year, and you're doing it for 5 years. So you would have y equals 300 times 1 plus 0.08 to the 5th. Now I want to show this on Desmos because I just want to talk about, this isn't telling us, this is just a basic question. Like it's not like telling us what they're using the students for. And so in something like that, I would just use your rounding rules. Like I would, if it's above 0.5, I would round up. Okay, this isn't like the dog food question we talked about earlier. Sorry, I was doing Algebra 2 where we add it. So in Algebra 2, you actually don't write 1 plus 0.08. You just put it together and say 1.08, but I'm sorry. All right, so my answer is 440.79. So I would go ahead and just round that to 441 because we don't really know what they're doing with this information, and it's an estimate anyway. And so I would round it up. Now, some teachers are going to teach to round it to 440, and I would have to accept that, okay? So same thing on the next one. A population of small town is 1,600, and it's increasing at a rate of 3% per year. Find it after 10 years. So my time is 10 years. My initial value is 1,600, and I am increasing at 3%. So when I do this problem, I'm going to have 1,600 times 1 plus 0.03 to the 10th. Okay, so again, it's just a population, so it's not like feeding anybody. You're just finding out about how many people. So I would just use your rounding rule. So 1 plus 0.03 to the 10th is, I would say, 2150. Okay, so the answer on that is 2150. And sometimes some teachers will tell you to round up, down, whatever. On this problem, it's not really giving us the rest of the story, like why they're trying to find it. So I wouldn't worry so much about it. All right, so let's look at exponential decay. The formula for exponential decay is almost exactly the same, except instead of adding the rate, you're going to subtract the rate. And like I said, I don't know when this is in July. You're probably watching this in January, February, March, April. I have no idea when we're going to get to this. But I will say that we're going to do a lab that shows this so you understand why you're doing 1 minus r, but it's not something I can do over the computer. So just trust me on this. You're going to minus r, but when we meet, I'm going to show you. We're going to play a little game and figure this all out. So it's still all the same stuff. So my A, I have my A, and that is my initial value. Okay. How much you walked in with, how much you started with. I have my R, and that's my decay rate, so how much you're losing. And so you're going to lose it from 1. And that 1 will never change because that 1 stands for 100% because it was 100% of what was there. And then T is time. Usually it's going to be in years, but I have seen some questions over the years where it was not. So the population of a town is decreasing at a rate of 1% per year. So it's decreasing at a rate of 1% per year. In the year 2000, there were 1,300 people. Use an exponential function to find the year 2008. So I'm going to highlight both of those. That has been 8 years. They're trying to be all tricky. So you have 1,300, and it's 1 minus 0.01 to the 8th. So again, this is another people question where you're just looking at population. So you're going to do the same thing we've been doing. You're going to go 1,300 parentheses 1 minus 0.01 to the 8th, and that's 0.56. So you're going to round that to 1,200 people. So the only difference is since we're decaying, we're losing the rate. So what I would like you to do right now, because I don't think you need me to do 1,000 examples of this, I would like you to do that one and let's go 10. 8 and 10. I would like you to do 8 and 10, and then we'll be done with notes. Pause and do them. All right, the car's value is $18,000. It's decreasing at a rate, depreciating at a rate of 12% per year, and it's doing this for 10 years. This is money, so you would round it 2 places. So 18,000, it would be 1 minus 0.12 to the 10th. So you're going to type that in your calculator, and the book got 5,100 or 5,013 cents. Sorry. Okay. And so now you're going to do the investment question. So you take an investment of 8,200, loses 2% per year. And it says use an exponential function to find the amount of the investment after 9 years. So now you have an investment that started at $8,200 and it's losing 2% per year for 9 years. So you're going to type that into your calculator, and the answer on that was $6,836.73. Okay, so this is exponential growth and decay.